Using the law of sines. The law of sines is actually fairly easy to understand where it comes from. But there's a couple important things you have to realize about law of sines and law of cosines. One of them is how the angles are labeled. So in a triangle, the way it works with law of sines and law of cosines is if I call an angle A, let's change that color. If I call an angle A, then the side opposite is little a. If I call an angle B, then the side opposite is little b. And if I call an angle C, then again the side opposite is little c. Now, this is the height of the triangle. And we know that sine is opposite over hypotenuse. Look at the right angle right here. So the sine of angle A is opposite over hypotenuse. And if I cross multiply, put this over 1 and cross multiply, I see that H is B sine A. And I can repeat that for the other side. I see that the sine of angle B is equal to, here's angle B, it's the opposite, so that would be H over the hypotenuse, which is A, little a. And again, we'll put this over 1 and cross multiply, and we see that H is A sine B. Well, notice this is the same H. So we could substitute, and if we substitute, then we're going to say that B sine A is equal to A sine B. And this is the law of sines, but to make this friendlier, we'll take both sides and we'll divide by AB. Little a and little b. Over here, the b's cancel, and here the a's cancel, and we see that the sine of angle A over little a, remember that's its opposite side, is equal to the sine of B over little b. That's its opposite side. Now, if you were to draw on another height and you were to do this all again, you would discover that the sine of angle A over A is equal to the sine of angle B over B is equal to the sine of angle C over C. So the trick is that the law of sines is all about opposites, because angle A is opposite, its opposite side is little a. And angle B, its opposite side is little b. And the same thing for angle C and little c. So it's all about opposites. So what you need are two pairs of opposites. Any one thing can be missing, an angle or a side, and you can solve for it. Here are a couple of examples. In this question, we're looking for AB, so we'll call that X. Notice that we have an angle of 30 degrees and we have the opposite side 75. Notice that we have an angle that is 35 degrees and its opposite side is X. It's all about opposites. You need to have two pairs of opposites. Any one thing can be missing and you can solve for it. So here we'll say that the sine of 30 degrees over 75 equals the sine of 35 degrees over its opposite x. Now when you do this, make sure, and the next one we're finding angles, and make sure everything's in degrees. So let's cross multiply and solve. So we'll cross multiply x sine 30 equals 75 sine 35. We're solving for x, and there's times right there. So we'll divide by the sine of 30. And x ends up being, punch that into the calculator. So x equals, and we're rounding to the nearest tenth, 86.03. So that 86.0 is the length of that side. In this example, we're finding an angle. We're going to find angle B. Now, remember that when you find an angle, you're going to use the inverse function. But that's only when you're getting your final answer. You're not going to do that initially. So the law of sines is all about opposites. Notice I have the opposite side of angle B. I have the 95. And I have 79 degrees. And its opposite side, 145. Law of sines, all about opposites. You have two pairs of opposites, you can find any one thing. So for our purposes, it'll be the sine of B over its opposite, 95, equals the sine of 79 over its opposite, 145. So just like in the last example, we'll cross multiply. 145 times the sine of B equals 95 times the sine of 79. And we're solving for the sine of B, so we need to get it by itself, and there's times right there. So we'll divide by 145. And we see that the sine of B is this. Now, the sine of an angle is going to be whatever that decimal is. What I need to do is do the inverse sine of the decimal to get the angle. So, the way to do that is to punch this in the calculator. And I discover that the sine of angle B is this decimal, 0.64313,505, and it goes on and on. And what I need to do is take the inverse sine of that decimal, 0.64313,505 and onward, and that will give me the measure of angle B. I'll show you how to do this on Desmos.com. So take to Desmos.com, first of all go to the tool icon and change it to degrees or things aren't going to work right. Then go to the box and plug it in. It should look something like this. Right here. And plug that in. And 40 point to the nearest tenth, 0 degrees is your answer. The measure of angle B is 40.0 degrees.